Welcome back for the sixth and final AP ECE Chemistry, Chapter 13, Acids and Bases problem set. Let's take a look at problems 97 and 98. In problem 97, you're asked which are true about a 0.1 molar solution of a strong acid denoted HY. So I write an equation out, HY, single arrow. Look, it only goes forward because it's a strong acid. It'll fully dissociate to give the hydrogen ion and the conjugate base Y minus. In part A, you're asked to consider is it true that the concentration of Y minus would be 0.1 molar, and the answer is yes. There's a full dissociation, so the Y minus should be the same concentration as the original strong acid HY. Part B, you're asked to consider if the HY concentration would be 0.1 molar, and that is not true. There should be none of it left. The concentration should be zero. It is all fully dissociated. Part C, you're asked to consider the hydrogen ion concentration, and since that's the same concentration as the conjugate base Y minus, it should also be 0.1. That's a full dissociation. Part D, you're asked if the pH is 1. That's true. If the concentration of the hydrogen ion is 0.1, you do the negative log of that, you're going to find, bang, that pH is 1. And then in part E, you're asked to find out if the concentration of H plus Y minus is to 0.2 molar. Each concentration is 0.1 independently, so sum them up together and you should get a concentration of combined H plus and Y minus that is, in fact, 0.2 molar. Alright, let's take a look at problem 98. Problem 98, you're given a set of a bunch of substances, beakers A through F. Each beaker contains 100 milliliters of substance, and each beaker's contents are 0.1 molar. You're told only that beaker A has hydroiodic acid. Beaker B has HNO3, beaker C contains NaOH, beaker D contains BaOH2, beaker E contains NH4Cl, and beaker F contains C2H5NH2. I've noted for you that some of these things are strong acids, some are strong bases, some are weak acids, some are weak bases, and given you Ka or Kb values if necessary. And then in part A, you're asked to consider the pH in beaker A versus the pH in beaker B. Well, in beaker A, you've got a strong acid. In beaker B, you've got a weak acid. So there's a strong acid, there's a weak acids. So the pH in beaker A should be lower because it's got a strong acid. Strong acids have lower pH values. In part B, you're asked to consider the pH in beaker C versus the pH in beaker D. Well, C has a strong base, and so, well, does D. D has a strong base as well. But D's strong base is something that will dissociate 2 hydroxides per every mole of barium hydroxide. So the pH in beaker C should be numerically lower than the pH in D, because in D there should be a higher concentration of hydroxides. There are twice as many hydroxides. For part C, you're asked to consider the percent ionization in beaker A versus beaker C. Now, beaker A and beaker C have an acid and base, so that might get confusing, but they're going to fully dissociate because they're both strong, so it should both be 100%. They will be equal to each other in terms of their percent ionization. In part D, you're asked to consider the pH in beaker B versus the pH in beaker E. Now, beaker B has a weak acid, and beaker E has a weak acid as well, so you need to compare those Ka values to decide which one will be stronger. Now, the book answer officially says more information, but since you can look up the Ka values for each of those things, you can make a comparison and find that the pH in B should be lower than the pH in E, because the Ka in beaker B for this acid HNO2 is lower than the Ka for the contents of beaker E. In part E, you're asked to consider the pH in beaker E compared with the pH in beaker F. All acids will have a lower pH. In E, it's an acid, and in F, it's a weak base. Now, you have to recognize that that's a weak base. The hydrogens here might confuse you, but you have to pay attention and notice that, hey, this thing could accept another hydrogen. In part F, you're asked to consider the pH in beaker C versus the pH in beaker F. In beaker C, you're dealing with a strong base, sodium hydroxide, and in F, you're dealing with a weak base. So both things should have above 7 for a pH, but C should have an even higher pH because it's a stronger base.